factoring, in this video we're going to talk specifically about factoring of trinomials. Your trinomials are going to have two different appearances. The first appearance is that your a term or your squared term has a coefficient of 1, and the second is your squared term has a coefficient of something greater than 1. Now, there's a couple different ways that you can factor trinomials. Some of those ways include trial by error, the grouping method, or bottoms up. Okay, bottoms up is the same thing here as what's called the AC method. Now, me personally, I love doing this third method because for me it's very straightforward, very simple, and the steps are easy to follow. Okay, so I am going to rely heavily on that method. However, the other two methods do apply. So, the steps for using the method. So again, we're talking about bottoms up. Says first you want to make sure that you factor out all GCFs. Okay, you want to put your equation down as low as it can go because that is going to reduce the amount of reducing fractions that you may have to deal with later. It is also going to reduce down the how large your numbers are going to end up being as you walk through the method. Now, the other piece is that if you have a negative on your leading term, then you want to factor that negative out regardless. So pay very close attention to your GCFs and if your leading term is a negative. After you've done all of that, you're going to multiply your a, so the coefficient of your squared term, times your constant. Okay, in other words, a times c. You're going to get a new value, and then you are going to find all the factors of that value. Once you list out or find all your factors, you are looking for the combination of factors that will give you your b term. Then you need to set up your factors, putting them into factor parentheses like these, and you have to divide those factors by that leading coefficient a. Okay. Once you're done with that, you need to reduce any fractions you see, and then the very last step is bottoms up, meaning any denominators that you still have are going to become the coefficient of the variable, i.e. bottoms up. So, as a shortcut, so this right here would be something that maybe I would screenshot, but it's up to you. Essentially, this method boils down to this. You're going to multiply the first and the last a times c. You're going to find your factors that are going to give you the b term. To do that, you want to look at your sign. Okay, so again, the last sign tells you if your factors add or subtract. You want to plug it into this form where you're going to have whatever your variable was. In most cases it's x, but they could be different letters. Plus or minus stands for the fact that we don't know what the signs of your factors are going to be. And then it's your factor divided by a, so that first term here. You want to reduce these fractions as far as they can go, and then any remaining denominators are going to flip up and become the coefficients to your variable term. Now, for this second step where we're finding the factors, the biggest tip and trick I can give you here is this one right here. That says what you have to remember about a quadratic is that each of these signs has meaning. This last sign tells you which combination of signs you can choose from. So, we have this table down here that is showing you the different combinations of signs that we have. So we have that if you have positive times positive, you get positive as a result. Negative times negative gives you positive as a result. However, positive times negative gives you negative as a result. So depending on what this sign is going to depend which grouping, either the positive or the negative, that you have to choose from. Once you figure out which grouping you have, the middle sign here is going to tell you which one you have to use. So for example, if this back sign was positive, but this middle sign was negative, then you would automatically know you have to use the negative factor. Okay? The last hint I have is this. If your B term is negative, then the bigger factor is negative. If your B term is positive, then your bigger factor is going to be positive. So with that, let's take a look at some examples and see how all of this comes into play. So we have y squared minus 14y plus 24. So the first thing that we can look at is we can look at it two ways. The first way is we could use that bottoms up method, which says I'm going to take a times c, so this is going to be 1 times 24, and when I do that multiplication I get 24. I then have to find all factors of 24. So I know that I have 1 and 24, I have 2 and 12, 3 and 8, 4 and 6. Now, of these, I have to know which one of these combinations is going to give me what I want. So, that's where looking at my signs comes into play. Now, here, my B term is negative. So I need to have a combination of these where one's positive and one's negative, and I get a negative 14. Now, with the back term being positive, it's going to automatically tell you that both signs have to be the same. So I'm looking for a negative 14, so I'm looking at both signs being negative, because that's the only way to get a negative. And then if I look at these one at a time, negative 1 minus 24 doesn't work. Negative 2 minus 12 does, which means this would be my factor pair that I have to use. I then have to set up my factors, which say I'm going to set up x. Because my factor sign is negative, I'm using minus, and then it's going to be your factor, so 2 over my a term, which was 1, and then do it again. I'm going to have x. Here I'm negative. My factor is 12. My a term was 1. I have to reduce these fractions, so they're going to reduce down. So here I've got x minus 2, and I have x minus 12. Now the very last thing that we want to do is we want to do a variable check. In this problem I was using y's. However, because of the formula, I switched over to x's, so the very last step that you would use would be to change them back to y. So this is y minus 2 and y minus 12. And this is what we were looking for. Alright, now the other way that we could do it is we could do an idea called reversing your FOIL, and that idea comes from knowing what FOIL means. So I have x squared minus x minus 72. So when I look at them, reversing my FOIL means I have to remember a couple things. First, in order to get this 72, said that I had to multiply my factors. In order to get to this 1, says that I have to add or subtract your factors. Now the other thing that I have to remember is I just simply have to remember, what does this sign mean? Well, because this is negative, this is telling me that the option to use is positive times negative equals negative. This sign here is going to tell me which factor is negative. So again, because my B term is negative, in other words, what it means is that I'm looking for the bigger factor. Now, with that, I can set up my little factors. So here I'm going to have 2 of them. My variable was x, so I can put an x and x in both. And then again, I have 1 positive, 1 negative. So I've got my 1 positive and 1 negative. And then I need to know factors of 72. So I'm looking at 72 here, and I need factors of them. So 1 and 72. Two and 36. 3 and 24. 4 and 18. 6 and 12. And then 8 and 9. Oops, can't see that there. Hang on. There we go. Alright, so again, I have to have 1 positive, 1 negative, but my middle term tells me that my bigger factor has to be negative. So in writing a factor tree like this, it makes it very helpful, because it means that I know, since my bigger factor has to be negative, that all of my small side factors are positive, and all the big side factors would be negative, and now all I have to do is find which combination of these gives me a -1. So in looking at those, the only combination has to be these two down here, 8 and 9. So that means I have 8 and -9. Okay, so this is another way that you could attack factoring trinomials. Now, I caution that you only try to use, say, a reverse FOIL type method if the coefficient on your x term is 1. If it's larger than 1, then your smarter idea is going to be to use this bottoms up idea. Alright, let's look at another. Alright, so I have 6x squared plus 24 plus 18. So the first thing that I'm going to notice here is that I actually have a GCF of 6. So I'm going to pull that out. When I pull it out, it leaves me behind x squared plus a 4x plus 3. Very simply, if you take a look at it, first I've got my signs. So again, this sign gives me my options, which are going to be positive times positive equals positive, or negative times negative equals positive. And then this sign tells me to choose the positive option. And the reason for that is because you can't add to a positive if you're adding two negatives. So we have to choose our option. And then, if I look, I have factors of 3. So if I look at my factors of 3, that's going to be 1 and 3, and there's no other factors. So here we could go straight into setting your individual factors here using the information we have. So again, my variable is an x. My option is positive, positive. So positive, positive. And then my only factors that I have here are 1 and 3. Alright, let's look at another one here. So I have 12x squared minus 38x plus 20. So here I'm looking for a GCF to make it easier, and this would be 2. So I can pull that 2 out, and when I do, it's going to leave behind 6x squared minus a 19x plus 10. So I have a coefficient greater than 1 on my square term, so I'm going to use the AC method idea. So bottoms up. So that says take your first term times your last term, which gives you 60. Find all your factors of 60. So I've got 1 and 60. I've got 2 and 30. I've got 3 and 20. I've got 4 and 15. I have 5 and 12. 6 and 10. And so now I need to take a look at my signs. So again, my first sign here tells me that I have to choose. So for this sign here, I am choosing positive times positive or negative times negative. This sign over here is going to tell us which to use. Because it's negative, it means in this case I'm using my negative negative. And it's also going to tell me that the bigger factor, so the other thing that this sign is going to tell me is that the bigger factor is negative. Now, since both of my factors are negative, that idea doesn't necessarily hold a lot of weight. However, it is still something that is important to remember. So here, what I have to look at is the fact that all of these are negative. And I need to know which combination of these, when combined together, is going to give me a negative 19. So here the only combination that's going to work is going to be negative 4 and negative 15. So then again, if you continue with the method, it says we need to set up the factor. So here we're going to have x. My sign was negative. My first factor is a 4. My a term is a 6. Don't forget the 2 out in front, and then we'll do it again. I'm going to set up my factor. Again, my sign is negative. My factor was 15. My a term is 6. I now have to reduce my fractions. So here this is going to be 2 times x minus 4 over 6 is going to reduce to 2 over 3. And then this is x minus 15 over 6 is going to reduce to 5 over 2. Now the last thing we have to look at is I still have denominators, so this denominator has to shift up and become the pair or the coefficient to my x term. So here this becomes 2 times, it's 3x minus 2 and 2x minus 5. And this ends up being the factored form that we were looking for. Now to check your work, you just simply multiply everything back out together and you should come up with exactly what you started with. Alright, let's look at another one here. So in this one, I don't have any greatest common factors to fact out. So because my a term is greater than 1, I'm going to start right away with that AC method. which says take your A term, so 7 times your C term, -6, which is going to give you that -42. And then in this case, I need my factors. So I have 1 and 42, I have 2 and 21, I have 3 and 14. Now, you can keep listing all of them out, but if you think you found one that's going to work, then you could stop. So here, because my back term was negative, what this tells me here, so this right here tells me that I have to use positive times negative. And now this is where this term is going to come into play, because this is going to say that the bigger factor is negative. So here that automatically tells me then that my smaller factors here are positive and my bigger factors here are negative. And clearly you can see that a positive 3 minus 14 is going to give me that -11. So now I can set up my factors. So again, x, my first one is positive, and it's 3/7. And then I have x, my second one is negative, and I've got 14/7. Reduce the fractions. This first one doesn't reduce, so I can automatically take this denominator and move it straight up. So this is going to become 7x plus 3. On my back fraction, 14/7 reduces, so this becomes x minus 2. And there we have it. Here is my factor form. Alright, last but not least, let's look at this one. Again, if you look, none of them have anything in common. So we can start right in. So here my AC method says take your first term, 4, times your back term, 25. So this is going to give me 100. Notice it is positive. So here I can look at my factors of 100. So I've got 1 and 100. I have 2 and 50. I have 4 and 25. 5 and 20, 10 and 10. Again, my back term is positive, which means the option I'm choosing from. So if we look at it here, this says we are going to choose positive times positive or negative times negative. My back term tells me what to choose. It's positive, which means we're choosing the positive positive. So all of these are positive. And I need a combination of these that's going to give me 40. Well, if you look, adding all of these together, none of these work. So if you look at them, this becomes 101. Here we end up with 52. Here we end up with 29. Here we get 25. And here we get 20. Therefore, because none of these work, this one is actually not factorable. Alright, so there you go. That is everything that you would need to get started when working with factoring. So if you have any questions, let me know. Otherwise, I hope you enjoyed, and I'll see you next time.